then I would like to introduce my next speaker. My next speaker is Michaeli Baki from Chai, also a camera manufacturer, right in the north of Europe. And Michaeli is going to talk about big trends in small cameras. So the floor is yours.
Thank you, and good morning, everyone. So my name is Mihai, and I'm product manager at JAI. You might know the company, as we have been out there for around 60 years, but just to shortly recap, we are a Danish company with headquarters in Copenhagen, and we have research, development, and production in Japan, supported sales spread all around the world. And in my next 15 to 20 minutes, I will talk about the big trends we see in small cameras. So compared to the previous speakers, I will focus a bit more on solely the cameras themselves and small and compact cameras within them. So out of the many trends we see in the machine vision market, one of the most noticeable and overriding one is that of the small cameras. If you walk around in automation or machine vision affiliated vision shows, you will see that most of the vision systems are based on small and compact cameras. So we can say that small cameras now indeed dominate the machine vision market. Of course, there are still plenty of vision systems which are based on large, higher-end premium cameras with multispectral solutions, prism-based RGB, high-speed line scan, and so on. But by far, the highest volume of machine vision cameras being sold are those small in size and small or, well, smallish in price. Having said that, many of these small cameras are used in critical production systems where they have to run reliably 24/7 and 365 days a year. Hence, there is much more to it than just having a small form factor. I will try to answer 4 key questions, which will hopefully help addressing the larger question on what are the big trends in small cameras. And the 4 key questions are: what is behind the small camera trend? Which applications are leading the way? How are the requirements of small cameras changing? And where are they headed in the future? So basically, the organic evolvement of sensor manufacturing technologies make it possible. The pixel sizes are shrinking, and thus larger and larger resolutions can be shrinked into the same housings. And at the same time, signal processing electronics are also miniaturized. Furthermore, large machine vision builders who are seeking growth opportunities, they are entering into more competitive markets where it's a must to have a diverse product portfolio. However, these entry-level systems are smaller in size, they are more compact, they are lightweight. But new applications are not only about small size, but they also have to be more mobile and consume less power. Thus, we can say that machine vision today does not just only serve the high-end and premium market, but also entry-level application within the same market segments, where the end users of those cameras are quite often the same of the users of the high-end premium cameras. So we can say that the requirements are actually barely changing in terms of reliability, durability, or performance. So the advent of Industry 4.0 has also fueled the emphasis on small cameras. Machine vision, like other digital technologies, is a critical component of Industry 4.0. Cameras have basically elevated the level of quality assurance, robot guidance, surveillance, and thereby they are allowing a rapid implementation of Industry 4.0. So the trend of small cameras is flourishing across a wide range of applications. But it's especially noticeable in 2 key areas, and now I will highlight these. One of the biggest drivers for miniaturization of machine vision cameras has been the proliferation of robotics. The combination of small and compact vision systems with industrial robots has become a mainstay of industrial manufacturing. But this is not a takeover. This is rather a result of several decades of successfully applying automation to optimize processes, improve output quality, maximize yield, and lower risks in a variety of industries. Early industrial robots, we can say that they were limited to performing predefined tasks on well-known objects whose location is also known. And the success of these systems have led system builders to look for new ways to add value to robot systems. And these new configurations can be collaborative robots, cobots in short, pick-and-place systems, and of course they are used in assembly, disassembly, and quality inspections. Today, the vision-guided robotics, or VGR in short segment, it is valued at $6 billion annually and predicted to double by the year of 2026. And in addition to traditional robotic arms, autonomous robots are also gaining importance. These can be found in factories, helping to automate the transportation of components. And also in recent years, an increasing number of autonomous farming vehicles have emerged. These include vehicles used to identify weeds and remove those, but all the way up to drones flying over fields, inspecting and taking images of a specific topography. Of course, space, weight, and cost savings are essential in all these applications. So while the robotics industry is considered to be the biggest driver of the trends towards small cameras, another good example is microscopy. In microscopy applications, system builders are also looking to develop smaller and smaller, more compact tabletop systems. And even though a significant portion of the imagers used in these systems are still based on electron multiplying CCD or SCMOS or standard CCD sensors, there is a volume market for CMOS cameras as well. And besides industrial microscopy, medical microscopy, and medical endoscopy, digital pathology is also another area within medical analytics, which relies on small and compact cameras. But these markets have added one very big requirement to these small cameras, and that is the level of dust screening. And I will get back to that in one of the later slides. So my dimensions are of significant importance for these applications, but there is much more to it than just having a small form factor. So let's look at those trends we see in small cameras. So small, but highly reliable. Whether we are talking about arm-mounted cameras or stationary cameras mounted to a robot's fixture, these are often in harsh industrial environments and running in critical systems where it is essential to have a strong measure of durability and reliability. And for this reason, system designers are learning to ask more and more about shock and vibration rating, thermal dissipation, and overall field failure rates. Small, but dust-free. So as I mentioned before, the microscopy market, as an example, has added this very big requirement to the typical small and affordable camera. Because factors such as high magnification and telecentric lenses can really make dust particles critically visible in these applications. And these particles would normally go completely unnoticed in traditional factory automation, ethnocentric systems. But they can have a very critical effect on the image quality in microscopy. Therefore, system builders are placing a special emphasis on the dust screening procedures applied on these small cameras. But some manufacturers also implement internal sealings to prevent the migration of dust into the optical path. Small, but using state-of-the-art technology. So many of the latest sensors out there are very small in size, consume less power, and at the same time improving in their imaging performance. It is because simply the integration of more complex sensor technologies has been simplified. And a very good example of that is the latest Precious sensors from Sony based on a backside stack illumination technology. And it's not too smooth on the screen, but well, it should be theoretically. But basically, it means that the photosensitive layer is right below the microlenses, as you can see on the right side, and the electronic circuitry is placed below the photosensitive layer. Therefore, you can achieve a better film factor and basically a better imaging performance with smaller pixel sizes. And that is leading to, of course, having larger resolution in the same same image circle, same image format. And as you can see in this quite simplified drawing, there is also more space for the circuitry on the bottom side of the sensor. And that is basically allowing much higher speeds. And these speeds are already exceeding the industrially favored gigabit Ethernet to 1 gigabit speeds. And that will be important on one of the next slides. And the fourth trend I'm showing here is about advanced application-specific features. I'm highlighting one feature here, and this is related to outdoors applications. And when we are talking about autonomous robots, whose imaging is based on the ambient lighting, then it's a very basic requirement that the camera has to be able to react to the dynamic changes of light. And functions like automatic gain control and automatic shutter control help to respond to these dynamic changes. And features like that help to manage sophisticated applications much more effectively. So we can say that small and affordable cameras will continue to play a major role in the evolution of the machine vision market for many, many years to come. So let's take a look at what does the future of these cameras look like, in our opinion. Embedded vision has been a hot and trending topic in the industry for quite some time. And we can see that rarely has a vision system in the past been related to so much change potential. Historically, vision systems have consisted of a camera and a large and bulky industrial PC with the necessary extension card. But such large systems are, of course, quite expensive. And over time, we have not only seen cameras getting smaller, but processing platforms have also been miniaturized. And these processing platforms cannot overtake industrial PCs, and we shouldn't expect that. But they have 4 key benefits that are very attractive for integrators and system builders. And these are basically low power consumption, small size, lightweight, and low cost. And these advantages enable a deeper integration of small cameras and opening doors towards newer and newer applications. So as I mentioned before, the speeds of the previous S sensor line, which is basically the entry-level sensor line from Sony, it's already exceeding the gigabit Ethernet speed. But gigabit Ethernet is, and will be for quite a few years, the most common interface in the industry. It has a low cost of ownership, and it also enables long cable lengths up to 100 meters and above. In general, its data rate used to be well suited for most of the machine vision applications. But there are many applications that need more than that. And there are actually high-speed interfaces like CXP12, Camera Link, or 10 GigE out there for those applications. But the infrastructure required for them is much more expensive than the infrastructure for the 1 GigE interface. So implementing compression algorithms on camera FPGA is a way to have a more efficient data transmission, higher frame rates, and utilize bandwidths more effectively. And we at JI have decided to implement lossless compression just in order to avoid any kind of uncertainty regarding the image quality. Alternatively, also the integration of, let's say, medium speed interfaces has begun, such as CoExpress 6 or 5 GigE. The upgrade of those large and bulky vision systems has been a challenge for quite some years, especially finding replacement components for cameras. It's quite hard due to the optical constraints in pixel sizes, resolutions, image formats, and aspect ratios. And in most of the cases, these cameras are used again in critical inspection applications, because if we are talking about a machine vision system which is used for 10, 15 years, that's usually quite important to have a replacement for the camera that is smaller, faster, provides more flexibility in resolution, and at the same time, they should be also more affordable. And actually, thanks to the small cameras being equipped with more and more powerful FPGAs, there are many new possibilities rising. And such a functionality is sub-pixel rescaling, which can help to match the pixel size, the virtual pixel size, the resolution of an obsolete camera, especially if it is combined with a range of interest function, which is also implemented in basically all the machine vision cameras that are out there. So such a function can help for a drop-in replacement of older cameras. And such a function cannot only be implemented on a monochrome imaging like traditional binning, but also on color images. And as in general quality consciousness grows amongst industrial camera users, exploring the spectral dimensions of inspections has become evident. Industrial machine vision has been based for many years on the visible range, monochrome and color RGB sensors. But going beyond the visible, going down to UV and up to NIR and especially short-wave infrared has not been too easy due to the complex operability and high cost of these sensors. They normally needed cooling to achieve a decent image quality. But in the recent years, we can see that the technology is becoming cheaper, more accessible, and easier to operate. And of course, this is a very important enabler to build cameras based on these sensors. And in parallel, at the same time, we also see applications arising, because if it is becoming more affordable to buy a camera like that, there will be also applications making use of them. But we can expect a flattening of the curve, and that is just natural, because price reductions on a $300 camera don't make that much sense as they make on a $3,000 camera. And similarly, further reductions in camera sizes will be somewhat limited by the physical requirements of physical limitations of pixel sizes, and also the requirements of higher speed interfaces. Having said that, some manufacturers will slowly focus on lowering costs through high-volume mass production. But the financial impact of a possible breakdown of an autonomous system or of a critical production line, we believe it will continue to make reliability and durability a key evaluation metric for machine vision cameras, much more important than price reductions alone. And having said that, I'm at the end of my presentation. We have only a short time left, but maybe if you have questions, we can take them.
I would take one question. Is there a question from the audience? So again, Lily is here with the microphone. So if you have a question, please raise your hand. I don't see any questions here, nor in the live stream. So, Michaeli,
you are welcome also to come to our booth.
Yes. Thank you for your presentation. Thank you for introducing the trends in small cameras. So
Thanks
perfect.
for the opportunity.
Thank you.